And with that, we're going to move on to the work group reports. First up is Art Edison.
Okay, I will share my screen if I can. There we go. And I think I can get us back on track a little bit. Can you see that all right?
Yes.
Great. Okay. So this is just a summary of what we've done in the quantum mechanics working group over the last 4 years of the consortium. The participants are UC Davis. You heard a really good introduction in both the lightning talk and Oliver's talk about some of the things that they've been involved with. PNNL, you'll hear more details, I'm sure, from Tom and others in subsequent talks. And then the UGA Center is really us, Michigan State and Georgia Tech, in terms of this working group, and especially Michigan State. You'll hear the work from Kenny Merz's lab. So we all got to the initial kickoff meeting, if you remember that, 4 years ago before COVID, and we were all in the same place, and we realized that each of these 3 groups, the CIDCs, had a component of quantum mechanics or machine learning that they were bringing to the experimental protocols. So we decided that we would like to try to get together, share ideas, learn from each other. And during the first couple of years of this working group, we basically had presentations, topics given by mostly trainees, but talking about different aspects like MS fragmentation, clustering, retention time, NMR, chemical shift, CCS, et cetera, et cetera. And those were really informative and I think everybody enjoyed them. We switched gears after we went through the rounds of most people having a chance to present, and we did journal club presentations, which were also quite interesting and good. And then as many of you know who've heard updates over the years, we had this, we published a comprehensive review of quantum mechanics and machine learning in metabolomics that came out in Chemical Reviews last year. I think it's going to be a good reference for many years, and especially just right at that interface between experimentalists and computational chemists. So this is just the pretty pictures, or some of the pretty pictures from this, where focusing on these different aspects: MS fragmentation, NMR spectra, IR, collision cross section. And then with some detail about the different sort of bits of information that you can get and trade-offs between speed and cost of calculation and accuracy. And some of these methods have really gotten quite good, but as many of you know, also quite time-consuming over the years. So, but again, I think that a lot of the information that's in here will be useful for people for several years. So the result of this ended up what we ended up doing as a working group is applying for a supplement to the NIH, which we received. Thank you very much, NIH officials. And we recognized that each of us had developed and published methods from their own CIDC, and we wanted to figure out a way to kind of package these things up and get them out to the world. And so what we're doing, and this is really led by Kenny Merz's group at Michigan State University, they've created now something called the Portal for Open Computational Metabolomics Tools, or POMICS. And this is gathering workflows that have been developed in this consortium, or just other useful open source workflows. Everything has to be open source, and they can tie it together and put it together in this tool. So we're also going to be incorporating work from PNNL sometime in the near future. So I'm going to see if this works. I'm going to try to go to the website there. I guess you can see that, correct? So there's a website. You can just go to pomics.org. It tells you about the workflow. Right now, there's a CCS, computational CCS workflow that's been incorporated. This is something that the MERS group made recently with actually Carter who gave a talk, the lightning talk. And you can actually go to the tab, Calculate CCS, and you can enter your form. Right now, what this is it's a submission form where you give your name, email address, this other information. All that you really have to provide is the Smiles key in here, and then give them whatever other details you want to do, and send this off. And then so it's pretty simple. You can put in the Smiles information, and then let me see if I can go back. So I think I'm back now. What you get back is an email from one of the team members in the MERS group, and they will give you the results of this calculation. So it's not yet a web-based thing where you just automatically, without any person's intervention, where you get information directly back on your computer. But what happens is that so Susanta in this case received my inquiry, and then he just entered the Smiles string on their computer. Right now, there's the Michigan State University is requiring login and password, obviously, to get into their computational cluster. And so the simplest thing at the moment is just to have Susanta enter the Smiles string in there, and then it'll be the email will be sent back. So when you get an email back, then you get the result of what you've requested, CCS, whatever you've tried to get, plus a zip file with the full computational output from the calculation, from whatever you're requesting. So the next steps are going to be to add an NMR calculation pipeline, which have already been published by that group, and also PNNL has a nice NMR and CCS pipelines that we'll get in there as well. And eventually, the goal would be really to try to get this into AWS or another cloud-based computing engine, so that people can just enter information and get it directly back. But that's going to take some more funds for additional sustainability and long-term development. But the pieces are in place. And I think the important aspect of this is that it makes it possible to do these kind of calculations if you are not an expert in computational chemistry, if you don't have all of the software on your computer, and you just want to get some values, CCS, NMR chemical shifts. So I think it really opens it up a lot to general use. And that's it.
Very good. Question for Art? Work group? Okay, I guess we're gonna move on to Gary.
Can you see the screen and hear me okay?
We can.
Perfect. Hello, everyone. Thanks for the opportunity to present about our working group here today. The working group is the terminology working group. I've listed the members who have participated and contributed thus far. I don't have the cover of the Doors album to show you like Oliver did, but I can tell you that there's still work to be done, my friends, or whatever it was that the quote was that he used. So if you're interested in participating in this, if what I say today motivates you or interests you, please feel free to reach out, and we'd be happy to have you participate in our future meetings. This was the last of the working groups to form. It formed in the last year, and so our rosters have been busy with many other competing things in the consortium. So we're a little slow to get started, but we think we've got a good roadmap now, which I'll go through with you today. So what I'm going to, let's see if I can get this to advance. What I'm going to present here today, if I can get the screens, there we go, is to provide some motivation and goals of the working group, to provide 2 representative cases of why the working group we think is important, and then provide a 1-slide summary of our future plans and some of the timelines to accomplish those goals. So start with the motivation and the goals. This really started in the early days of the consortium, when we realized that multiple members of the DTC group were using the same terms to mean different things. And this created complexities as you can imagine, and us trying to have dialogue. And this is a group of us who were funded by the NIH for metabolomics projects. So, these are groups that work very heavily in the metabolomics space. And we realize that if we're having issues communicating with one another, that it's likely emblematic of what's happening in the field as a whole, particularly perhaps among those who are less experienced and less versed in metabolomics. Our goal, so that really motivated to set this up, and our goal is to try to find the terms that are ambiguous that are used in the field. So we're not trying to create a glossary of every keyword used in metabolomics. We're specifically looking for the words that are ambiguous because they are used in different ways to mean different things. And we're trying to collect those different definitions and try to aggregate them for convenience. A really important point is that we do not intend to impose any type of normative influence. So it is not our goal to tell people to find the term, and to find whatever it is, 2, 3, 4 definitions that exist, and then to tell the world that this is the definition that should be used. But rather to collect the definitions, the different ways in which words are used, and then make that available for the community. So we see this as an important first step. Ultimately, it would be great to have, we all believe that it would be really important to have kind of like an IUPAC system for metabolomics words and for our lexicon. However, we don't believe that the consortium is the best place to do that. It's not big enough. We'd have to bring in a bunch of outside folks to try to accomplish that, and we didn't think this was the right mechanism, but we thought it would be a really good place for the first step. So the question is whether or not anybody else is doing anything similar. As far as we know, the only sort of comparable effort is the one I've listed here, which has this acronym BP4NTA. You can say that, which stands for Benchmarking and Publications for Non-Targeted Analysis. And I've listed the members who are participating in this effort, and you can see them. They're all those are the academic members. There are some other members from industry who I haven't listed here. I've highlighted Husha Du in yellow because she's also a member of our working group. So that's an advantage that we have inside knowledge and a little bit in terms of what they're trying to do and what their goals are. You can see that they actually have several different objectives, and you can see that a little bit from the tabs up at the top of the website that I screenshotted here. But the one that's most relevant to this working group is the glossary. And I've listed, just taken a screenshot of some of the things that they're doing. So accuracy, analytical sequence, annotation of the feature, and then they've included definitions there. And you can see what some of those definitions are. A couple points to make in differentiating our work from the work of BP4NTA is that we are only focusing on terms that are ambiguous, that are used differently in the field. They're listing lots of terms, as you can see, things like boundary, accuracy, terms that are relevant to metabolomics as a whole. This group tends to be more representative of people who are doing environmental health scientists or exposomics, hence the term non-targeted analysis. And for each term, we're going to provide multiple definitions, as I said, not just list one and say this is the way the world must operate. But if anyone else is aware of any efforts that are ongoing that are similar to this, or that you think we should consider or integrate in what we're doing, it would be great to hear about that. So now I'd just like to say a few words about representative cases. I'm just going to do 2 relatively fast representative cases. And the first representative case is actually the first term that came up in the DTC group when we were discussing this. And that is, what do we mean when we're referring to an unknown? What is an unknown? This is a word that many of us in metabolomics use regularly, but we've found that the way in which it's used tends to vary depending on your background and depending on what kind of science you're doing. And so I'm just going to provide some definitions here. These aren't meant to include everything, so I've got a catch-all option at the bottom. What is an unknown? Is it molecules that are not present in libraries or databases? And actually, you can see one of the things that I've learned from this consortium is how to make presentations. We've had to adjust to the virtual environment throughout the consortium evolution, And Krista has taught a lot of the DTC. Krista's in, I don't know if she's here today, but she's taught a lot of the DTC group how to do these sorts of things. So this is a poll that came up, and appreciate it if you could answer. But what do we mean by an unknown? Metabolites are not present in libraries or databases. Metabolites that have not been yet reported in the literature. Any metabolomics feature that has yet to be identified, or other. And I just ask, if you use the word other, you choose that option that you're prepared to provide some definition. And if it's just a subtle variation, like you don't want to say libraries or databases, you want to say repositories or something like that, then please don't choose other, but pick the one that's most pertinent. So this is also when we get to see how many people are actually listening, because there are supposedly something like 74 people, I think, in this session. And I don't know, Alicia, is it possible to, I can't actually see the results.
Mm-hmm. It's we have
Yes,
68 people and 34 so far, 35. It's still going up. Have responded. Half so far.
Excellent. Yeah. I'd actually be quite curious to see what people say.
All right, looks like it's stabled off. C is 66%.
66%. And are the others, how many?
22% for A, 11% for B, and no one brave enough to say D because they would.
Yeah.
I was counting on that taking the bulk of the 15 minutes. No. Yeah.
So it's done quickly in the virtual world now.
Yeah. Actually, only 30 people respond. So as you can see, but this is a group of scientists who are well versed in metabolomics, and we still have a pretty big split between A, B, and C, at least the combination of A and B and C. So it's interesting to think, and it actually has a big impact on what you classify, because if you use the word unknown and you're referring to A or B, the number of unknowns is considerably smaller. If you're using the definition C, if that's your operating definition of unknowns, then every feature that you detect in a metabolomics experiment starts as an unknown. So when people are using this definition, they say things like there are tens of thousands of unknowns, which makes sense because glucose starts as an unknown feature, citrate starts as an unknown feature, isocitrate, which is very different than the definitions A and B. So when we think about this, and I have to figure out how to go back. Okay, when we think about this, just some clarifiers. Does it depend on the context we use? Does it require modifiers? Some people say, for example, unknown metabolites, unknown features, unknown compounds. You can put clarifiers in there. Oh, great, it popped up. I now see the results of the poll. Or do you? And if you say if 22% of the people said it's any metabolite, I think actually Oliver alluded to this in his talk. Not in the database, but what database? I mean, is it your in-house library? If your in-house library only has 100 things in it, then it's pretty easy to say that you found an unknown. So these are the types of things that we're thinking about. And this has been a discussion for a long time. This was an article published, a screenshot from an article published in 2012 by Stephen Stein. It's become known as Rumsfeld's quadrants because of the confusing unknown knowns and unknown unknowns and unknowns. And these, I just say that these aren't sufficient explanations in themselves, because you see it's got all these arrows and qualifiers to try to explain what these words mean. But this is the sort of thing that we're thinking about in the working group. So the second quick example I'll give, and I just have a couple minutes left, is the definition of annotation versus identification. I think most of us would probably agree on what the definition of annotation is, that it has some sort of putative assignment to it, at least with respect to identification. And generally, we think of it as classification of a feature. So it could be a classification of a feature perhaps as an adduct, a type of adduct, as a fragment. It could be as a type of molecule, type of lipid class, et cetera. And that seems like it should be distinct from actually identifying a metabolite. But where things get a little confusing is if you think about the identification levels that were suggested by the Metabolomics Standard Initiative, and this is just a screen grab that I took from a recent paper from the Reisdorfs in 2019, where we have level 4, 3, 2, and 1, with level 1 being the highest. You can see that level 2, even though we call it a level 2 identification, it actually looks a lot like an annotation. In fact, Nicole here actually says that it's an annotation. So that leads to some confusion as well. So Just ending here with some future plans and timelines. These are the words that we are attempting to tackle in the working group. Like I said, I've shown you some of the things that we've discussed for a couple of the terms. We haven't yet got to the writing stage, but if there are other words that you think should be included and you want to participate, please come along and discuss, or if you just want to send them to me and have the working group think about them, that's fine too. We're debating whether or not we should only focus on the important terms, but ultimately we do want to get this wrapped up and hopefully submit a white paper on the different definitions here in this calendar year. So with that, thanks to everyone, and I think I used just about all the time. Thank you.
Oh, you have a few minutes. I think it's 2:30. You have a few minutes. We have a couple of questions, and I do want to ask a question.
Sure.
So, in thinking about the terms that you're willing to tackle and discuss and work on, you also want to be pushing out terms that are well defined in other disciplines. Is that correct? So, if there are informatics terms or statistical terms or even analytic chemistry terms that are settled, they should not be redefined in this community. Is that's sort of the thinking here?
Yeah, so again, we're not imposing any normative actions here, but Shusha has brought up some examples where different communities use the word differently than the metabolomics researchers. And so we are, for example, disclosing that and saying, this is a word that's used by these other communities according to X, Y, and Z, but in metabolomics, be careful because sometimes people use it to mean this other.
I see it.
Exactly. Yeah. So actually, if there's anything on the list that you think we've left out, Mike, please shoot it over and we'll try to incorporate it.
Okay. We're going to head to the lightning talks.